Okay, here we are into Go Math Lesson 2.2. We are ordering and comparing fractions and mixed numbers. The easiest way to do this when we're looking especially at fractions is to find a common denominator. So if I had something like 1 and 1/3, 1 and 2/5, and 2 and 1/8. I have three different numbers here. I want to find the order from least to greatest, or compare them, right? First thing I'm going to compare is my whole numbers. That's the easy part. We all know that 2 is bigger than 1. So I know that 2 and 1/8 is already my biggest number. I'm going to cross it off. The question being, is 1/3 less than 2/5? Is 2/5 greater than 1/3? However you wanted to say it. Now, I would know that 1 out of 3 is closer to 0, and 2/5, well, that's less than a half. They're both less than a half. So now I need to find a common denominator. Common denominator is a least common multiple. Now you can find any common multiple to do this, but if we're looking back to Unit 1, we find the least common multiple can be our common denominator. So least common multiple of 3 and 5, well, looking at 3, multiples of 3 have 3, 6, 9, 12, 15. The only one of those that's a multiple of 5 is 15. So, how can I turn these? Better yet, let's rate them right next to each other. So I'm going to turn 1 and 1/3 into 1 and some 15ths. So 3 times 5 gets me 15, and whatever I do to the bottom, I do to the top. That's 1 and 5/15ths. Now, so as not to confuse you, I took 1/3, I multiplied by 5, both the numerator and the denominator, and I got 1 and 5/15ths. 5/15ths does simplify, greatest common factor of 5 into 1/3. So I checked my work there. Now over here, if I want to turn this into 15ths, 5 times what becomes 15? Well, that's 3. 5 times 3 is 15, and whatever I do to the bottom, I do to the top. 2 times 3 is 6. So now, I ended up with, let me cross those out so you can't see them. 1 and 1/3 became 1 and 5/15ths. 1 and 2/5 became 1 and 6/15ths. Well, now that's easy to compare because I know that I have a common denominator of 15, so I'm looking at a numerator. 5 is less than 6. So I end up with 1 and 5/15ths, which was 1 and 1/3, and 1 and 6/15ths, which is 1 and 2/5. Now it's important when I put them back in order, for my answer, I go back to the original. So yes, I did make this 5/15ths, but it was 1 and 1/3, and this is 1 and 2/5. So I moved 2/5 into 6/15ths, and I moved 1/3 into 5/15ths. So, what does that look like in an actual problem in your book? It looks something like this. Order 6 1/2, 5 2/3, and 5 5/8 from least to greatest. Okay, so obviously the first thing I'm going to do is compare the whole numbers. And I know between 5, 5, and 6, just like in the last problem, 6 1/2 is our greatest. So I'm done with that. I don't have to worry about that anymore. 6 1/2. I'm down to 5 2/3 and 5 5/8. Well, if I'm asking myself, are either of those less than a half or either of those greater than a half? Well, 2 is not less than half of 3, 5 is not less than half of 8. That can sometimes be an easy comparison. If I had like 1/6 and 4/7, I know that 4 is more than half of 7 and 1 is less than half of 6, so 1/6 is less than 4/7. So I have 2/3 and 5/8 that I'm comparing because 5 is the same. So I'm just going to leave that out for right now. 2/3 and 5/8. Well, now I need to find a least common multiple for 3 and 8. When I'm going through my factors here, I find the multiples of 8 that are also multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24. The only one of those that I think is a multiple of 8 is 8, 16, 24. So I'm going to turn these into 24ths. And you would ask yourself, well, can't I just multiply 3 and 8 and find a common multiple? Yes, you can. And for this case, since we're not asked to find the least common multiple technically, that's a valid option. So I multiplied 3 times 8 to get 24. Whatever I do to the bottom, I do to the top. So 2 8s is 16/24. So I took 2/3, multiplied both the numerator and the denominator by 8 to get 16/24. So if I were looking at pennies and I had 24 pennies and I moved 16 of them over here, then I had 8 left over here, I would say that 2/3 of my pennies are over here. So these are the same things, they're equivalent fractions. Now for 8/24, I'm going to multiply 8 times 3 to get 24. Whatever I do to the bottom, I do to the top. That becomes 15/24. So now I understand 2/3 is equal to 16/24, whereas 5/8 is equal to 15/24. Now I have my answer. So I go to 5/8. 5 and 5/8 is the least. 5 and 2/3 is next. And then 6 1/2 up top. So when I move this out here, we'll get rid of that to clean that up. Remember, when I answer back, I want to turn them back into the original mixed numbers or fractions that I had. So again, you're finding a common denominator and piecing them together after you looked at the whole number. The last part of this that we want to talk about is our decimals. So when we're comparing decimals, it's really important. So let's say I had 261 thousandths and 2,532 10,000ths, right? Normally, we would say, well, that's obviously a much bigger number because there's 4 digits in there. There's only 3 digits in there, but realize they're both less than 1. I can keep going out here with digits. It doesn't necessarily make it a bigger number, it just makes it a longer number. So in comparing your decimals, you want to make sure that each number is compared. 0 is compared with 0, so those cancel. 2 cancels with 2, 6 and 5. Since that is bigger, this is the bigger number. 261 thousandths is bigger than 2,532 10,000ths because I go by every single digit when I line them up. I compare them. Make sure your decimals line up for that as well, okay? So again, comparing fractions, you're gonna find a common denominator and compare them that way. Once you have your common denominator, you can really see the true value for what they are. And when you're comparing your decimals, you're gonna line up your decimals and then compare every single place value as you move to the right.